Hi folks, welcome to my Pet Retro Journal. This is another video for Amiga where we celebrate all things Amiga in the month of May. Earlier this month I did a video where I compared the Amiga to a modern Linux system on an older Lenovo laptop, and you can watch that video here. I recommend you watch it because it'll put this video in context, although you can still glean stuff out of this video if you don't watch that one. And I got a lot of feedback on that, not necessarily on the video itself, but also on several Discord servers that I was on. One of the feedbacks was that the comparison wasn't really fair because I only ran, so what I did is I created a very simple infinite while loop that didn't do anything, and I ran 2 initially and then 5 on the Amiga, and I was having the lines program and a little basic program, and it just brought the Amiga to its knees, and I ran about 40 on the Linux server with 4 emulators, QL emulators running, thinking that emulators would take up a lot of resources. But again, that machine is so much faster that wasn't necessarily a fair comparison. So what I want to do today is do an apples to apples comparison, or closer at least, by figuring out what the speed difference is between that Lenovo with running modern Linux is compared to the Amiga. And then I'm going to try to hammer that Linux system just to get a closer look at that. One of the surprises was, there was comments was the surprise that the Amiga was just so bad with 2 infinite loops, much less 5. And there was thought maybe the Aztec C compiler is doing something inefficiently. Again, I can explore that further, but it's the only compiler I've used, and it seems to work fine, but yeah, I don't know what else. Other people had commented, oh, well, the lines program is notoriously bad, and so is the Amiga Basic. Well, that's true, but the lines program actually runs pretty well, and if it's on a preemptive multitasking environment, then it should be independent of what else I'm running. So it was the 2 and eventually 5 infinite loop programs that were slowing the lines programs down, not vice versa. Again, if you don't understand how the exec kernel does multitasking on the Amiga, it's kind of unique. Well, different than I'm used to. It does real-time priorities, and what that means is it's a very greedy algorithm in that the task with the highest priority gets 100% of the CPU, and all the other ones will just wait. On the QL, it does what's called user priorities, and Linux does both. But most jobs you run on Linux are under user priorities, and so what happens is that you actually have to have the same level of priority for tasks to run multitask concurrently. And that's actually what happened. If you looked on the video, I think they all had 0. So I had Shell, Z Shell, Lines, Amiga, Basic, and then the 4 loop programs. They all had 0 priority, and so they all were running sort of round robin. And, the only thing I can think of why it's so inefficient is because maybe it's either not giving enough time for the time slice as it's switching, or I think that's what it is. It's not that it's giving too much, it's not giving enough. If you watched the video last year on the executive suite, you can watch that here, that was a program that actually tries to fix that and give you user priorities. And the way it does that actually, and the reason I didn't use that is because it actually adds additional overhead. It creates a task called the executive that runs and gives itself the highest priority. On the Amiga, you go from -62 to 63, with 63 being the highest. Most jobs start at 0 if they're running. There are some that have higher priorities, but they're in a wait state. But if they're actually running, they're at 0. And and what it does is it goes through and looks at the other jobs that are running, and it takes one of them and it gives it also 63 priority, so that both of them are now running concurrently. Gives it a little bit of time, and then it'll bring it back down to 0 and grab the next one. So basically it gives it more time. And so what really happens is the foreground one, or the one that it's currently swapping with, gets to run a bit more, but the other ones that have a lower priority actually stop. So in some ways, it has the appearance of speeding things up, but in other ways, it actually slows things down even further. You just can't see it because the infinite while loop ones, they're just not doing anything. So it's just an odd priority system. Again, the QL uses what's called user priorities. And the reason it actually ran better, first of all the jobs had a priority of 8. The QL has a range of 0 to 255. All had a priority of 8 except for the shell which had 32. And that's why it was a bit more responsive. But the other weird thing about the QL that's different from Linux is that the jobs tell the operating system what priority they want to run on. And so they give themselves 8. And unless you change it, that's what it stays at. And so since I compiled all the baton, the command shell basic the little basic interpreter that I wrote, as well as the while loops were all written in Digital Precision's either C or supercharged basic compiler, they all were running at 8 priority. And the only thing that wasn't was the command shell. And ICE, I assume, was also running a little faster. But you can't do that on the Amiga because it's real priorities. They all have to have the same priority. So that's a little bit of a bottleneck. But yeah, so I don't know why the Amiga ran so badly, because I don't think it's a bad C compiler. I just think it's the exec kernel is just maybe the time slices are too small. I don't think there's a way to adjust that. Okay, so what I want to do is spend time today on the Linux system and really hammer it. And I'll also actually come back on the QL. And one of the things I said was that the while loop, I could only run 5 or 6, I forget how many, and I would run out of memory. But it turns out that each while loop was setting aside 8,000 bytes for data space. Well, you don't need that. So I actually created a version that uses only 10 bytes. And you'll see that I can run, I think I'm able to run up to 43 while loops at the same time. And you'll get to see how that impacts the QL. So it's actually mimics a little bit the Linux system. It's kind of cool. So I'll do a brief one of that as well. But yeah, today just want to really hammer that Linux system to see if we can bring it to its knees and do more of an apples to apples comparison to the Amiga. So let's do that. All right, I'm on my Lenovo, and the first thing I did is I was looking at figuring out how much faster this computer is compared to the Amiga, and I found some resources. There's a Passmark, which is a benchmarking measure, and it's actually, you can find these at CPU Benchmark, and it's actually by the company Passmark Software. For MIPS ratings of modern processors, I found this roylongbottom.org page, and then I was trying to figure out, I know that the Amiga has its own, sysinfo will tell you how many MIPS it is for the Amiga 600. However, since it's not an apples to apples because it's compiler dependent, I just went with a more general one. So I found that in general, the 68,000 is about 1.4 MIPS, and this was backed up on this Wikipedia article. I know that in reality, I think the 600 sysinfo says it's 0.56, but if you run different Drystone programs on sysinfo, you actually get better values. So I stuck with the 1.4 MIPS since these are all estimates. So initially, I tried to do a rough estimate. My rough estimate was basically just CPU speed comparison. The PAL version of the Amiga 600 is 7.09. The Intel Core is 1.2 gigahertz. So if you divide them, you get 169 times faster. Not very accurate. And so I tried to do better, and this is where I use my resources. So I tried to find a processor that was on that MIPS page that Roy Longbottom looked at, and the closest one I could find was a Pentium 4, because there's Intel Core i3, Intel Pentium, 1.9 gigahertz, and it had. I'm only going to focus on the single threads because all the software I'm running is single threaded. So the Intel Core i3 had a 392 Passmark, and the Pentium 4 at 294. So it's about 75% the Pentium of the i-Core. Now, there were ones that were closer, but they were like AMD chips, so I wanted to stick with the same manufacturer. So all I did is basically, since the Intel Pentium 4 had a MIPS rating of 2,593, I just extrapolated, normalized, and got 3,457, and so you divide 1.4 by that, and you get about 2,469 times faster, so that's a lot. So running 40, which I did in the video, these while loops was not sufficient. Okay. So what did I do? So basically, if I wanted to run, so this is single threads. There's 4 threads though, so I'd have to at least run 10 to get pretty close to that, I would assume. So basically, what I ended up doing was as follows. I ended up actually trying to run not 10, but 10,000, I should say, or 9,000, whatever. I actually tried to run 15,000 of those. And if you go here, and if I actually do a ps-elf and grep for loop, and pipe it to word count, you see that I have about 13,137. It's not 15,000 for a weird reason. I actually kept the other windows open. So here's one. So I did it in batches of as follows. So let me go back here and show you my shell program that ran this was it did it. Sorry, H. I'm typing sideways. So I did it in stages. I did 10 stages of 500 each to try to spawn 500. And that's what this log is, because I put it in a log. And what you'll see is it's interesting. First of all, this is the first loop log. And you'll see that the first 500, it takes about 13 seconds. And the next one, it ends up taking about 30 seconds. And then the next one, almost 50 seconds. And then almost 2 minutes. And then almost 2.5 minutes. It goes closer to 3 minutes, 4 minutes, etc. And the last one took about 5 minutes, and then it kind of crashes after. I think it could only do like 4,600 whatever, and they would run out of resources. And that was not a fluke, because I did a second one of these, and same thing. The only difference is the first one, again, about 19 seconds, but then it gets progressively slower. So I think as it has to add deeper into the queue of jobs, it just takes longer, because this last one, you can see it was 12 minutes. And on the third one, on the third one, it took 18 minutes for the last 500 before it crashed. So it's definitely so it's got 13,000 jobs running. Again, it has 2 cores with 4 threads. So I was focusing on 2 cores and not the threads as much. And so I figured 13,000 jobs, if it's 2,500 times faster, then if I want to run 2 jobs, I'd have to run 5,000. But since it has 2 cores, I'd have to run 10,000 for 2 jobs. So I kind of went a little bit more than 10,000 for 2 jobs, because again, I wasn't going to try to mimic the running 5 loops that I did on the Amiga. I did 2, and it was already pretty bad. And so here I did, because it's a dual core, I did 13,000, which, if you do the math, it's about running 3 to 4. 3 or 3.5 loops equivalent on the Amiga. And this is actually running pretty decently now. Now, the reason I'm not using these shells is because there's some resource limitation on these shells. So if I try to, again, I'll do it with this one. If I try to do an LS, you'll see that it takes quite a bit of time, whereas if I use a shell that I didn't run that script on, it's instantaneous. So these shells themselves, even though the way I ran this, I'm going to quit it, is, let me go to this one that is still live so we don't have to sit there and wait. If you look at how I ran this, I did a no-hop bash and piped it to the log file. And for whatever reason, it's just taking a long time to do anything. So I left these open so we could see that. But each one would get progressively slower in putting jobs on the queue, and then it would only go to about 4,000, into the 9th round. So it did 4,500, and then it crashed about 4,700. And I just thought that 13,000 was a pretty decent test. Now it does impact it. I do have resource monitor is maxed out. This time you can see it a little better. And I also have memory up to 2.9 out of 4 gigabytes. Still not using swap space, which I don't want to because the QL obviously didn't either. I've got the following emulator running. So this is just running Hello World. It's still running pretty fast. This is not doing anything, but you can see the cursor. And also if I go, it's still doing that. So in that sense, it hasn't really been impacted. And then this one, I believe if I run, it'll just, count up, and you can see that's pretty fast for an emulator. And again, these aren't going all out. This would go a little faster if I didn't have all these jobs running. But yeah, for the most part, things are going well. I didn't open the fourth one because I wanted to show you one thing. So this definitely mimics a little bit what the Amiga had going on. It's also the QL, and I'll show you that. If I go under emulators, it's actually kind of, so in QLA 2, like when I double click on this, it's like, did I double click on it? It doesn't immediately respond. So there's kind of a, and it finally runs. I'm like, oh, okay. So it kind of lost a little bit of the responsiveness of the, and of course I'm running 4 emulators. It really should be only running 2, so I'm kind of hitting it with these harder tasks as well. But yeah, so I think, and again, you probably won't hear it because when I do audio processing, I'll take out the background noise, but the fan's blowing like crazy because the processor is hot. But I think generally, we have a pretty decent, this is about, at 13,000, if this has 27,000 max jobs, I'm about 50% capacity for running tasks, and I'm more than halfway taking up memory. So I am hitting this. I hope that running on the Amiga, you can see this is slow now. So here's where things get a little dodgy. On the Amiga, running the Amiga Basic as well as the lines, a couple of shells, and 4 or 5 background loops. It was a bit surprising that. So here's an instance where it'll eventually come back, but right now So the monitor, which is obviously having to go through a lot of. This is actually trying to hit all of those 13,000 tasks and getting some info on it. Trying to close it, it sort of is stuck right now. And I might even get a message. So there's one idiosyncrasy where it's getting up. And I think it's obviously not impacting the rest of the system, but it is impacting, like here, this is still working, top is still working. So it's just that particular process that is hurting in terms of trying to do its thing, because it has to interface with it's working again. All right, can I close it? I'm just trying to. No. Well, can I? Yeah, I don't know if that'll do it or not. I'm sure I could kill it on the command shell if I wanted to, but it's really the interface somehow. Here it goes. Force quit. Yeah, so I can quit it. So it's still giving you. But yeah, so that's kind of where we are on the Linux system. So it is being tasked. It's doing okay, but you can definitely notice it. So that's pretty interesting. And that's actually why I like to do these videos, because I got to sort of explore stuff on the Linux system that I like, for instance, if you look at if I do a bash on these, I have these pairs of that tell me what my limit are, and you can see here that I upped the limit to 20,000. It was originally 9,663 or something, or 9,363. It's supposed to be. I looked at the configuration file. It says 33% of max, and Linux is supposed to have 32,368 as max, and this is a third of 9,000. That's like only 27,000. So I'm not sure what's going on there. And I upped that. You can run a command if you look at sys resize. You just do a system control and say task max, and then limit 1 is just itself a system control task. So I had to do a little bit of research on how to actually get all that information. That's a pretty cool part. In any case, I want to go do one more thing, which is look at the QL and see how it can handle a massive number of jobs too. So let's go there. On my QL, so I'm not going to do this right in the ICE environment. So what I want to do is I'm just going to, if I do a directory on 3, you can see that I have loop 10b. And what I did is I went into, basically you can edit the header of the loop file and change it from 8,000 and change it to 10 bytes. So the data space, which is I think where it keeps its local variables, is 10 bytes, since a while loop needs nothing. And so it's going to take much less space now. And so what I'm going to do is I'm just going to write a little loop for I equals 1 to 43, print 0, I, and we're going to go exec mdb3 loop 10b. All right, here we go. It's going to initiate 43 of those. And you can see it goes pretty fast, but it'll start slowing down. So it has a very similar feel to what the Linux system does. It's going to go 43. We'll see if I might fast forward over this part, depending how long the video gets. But it would be nice if I could show you sort of the pace of it, because it does slow down, but it doesn't get too crazy. But you can see that in each iteration, it just gets slightly slower as it's trying to, it has to contend with the other 20-some processes as this for loop's running, and then having to add it into the queue as well. And what I want to do once this is finished is just show you how this all, how ICE still runs given these 43 processes. So so it's running so it's the same little loop program that I wrote, just a while one with no body to that loop, and it just it's just running quickly, and you can see it's starting to slow down. And so we'll see if it might get a second wind here, but I might have to fast forward over that. So it's got about 11 more to go, 10 more. So again, it's still going pretty good pace. Yeah, so obviously after 5, the Amiga was down to its knees. I think the QL is going to feel a bit more like Linux. And if you think about it, it has 128K of memory versus 4 gig. So a megabyte is 1,000th of a gigabyte. So not only does it have 4,000 more than the Amiga, this has 32,000 more memory than the Amiga. And this, we decided that this was 2,450 times faster than the Amiga. Well, the QL is half the speed of the Amiga because of its 8-bit data bus. So now you're talking 5,000 times faster than the Amiga, and then the Linux system. So that gives you sort of an idea of how well the QL is actually handling this. We got two more to go, and then we'll get into ICE and see how that runs, and then I'll do one more thing, and yeah. So this gives you another apples to apples, but I really wanted to show you how the QL does its multitasking. So we should be done. That was the 43rd task. I didn't try to get rid of the window because then you have to deal with the compilation. All right, so it can still do. It's going to be slower, but now it's hitting it, and you can see because it's having to deal with all those tasks, but it's still doing its thing. It's going to give me control back here in a second. All right, so then if I go at 10, let I equal 0, 20, let I equal I plus 1, 30, print I, and 40 go to 20. It's not, it's taking a while to add to the again, the keyboard stuff is fine, but when it's actually trying to add it into the memory of the, so this is not delayed, it's just the, all right, if I run this, yeah, here it goes, running this basic program, running with 43 other while loops. And you can see that, you know, remember on the Amiga with 5 while loops, it was just printing 1 character at a time. So it'd be print 1, then 9, you know, if it's a 3-digit here, it's actually going pretty quickly, you know, considering that it's having to compete against that. All right, just wanted to show you that. I'm going to new the space. And again, it's going to flash all of the 43 windows. Again, if I wrote this in assembly, I could get rid of having windows, but I tried to keep it with sort of within the realm of a C program with a while loop. So this part's annoying. And that's just because the windowing system is also kind of weird on the QL. All right, so here we are. It's going to open, and you can see how it's going to be more slowly printing the icons. Boop. Yeah. But you'll see, additionally, though, the mouse is actually still moving kind of fast. All right, so I'm going to do the task one, so that's down here. Again, it's off the screen, and I'm trying to get, there it goes. Again, if I ran this in monitor mode, had a monitor, you would see it has a bottom menu. I've shown it before. So it has 2K free, so that's good. I could have run one more, but then I couldn't have run anything in ICE, because ICE doesn't use any memory until it does these kind of things. It has 45 jobs. Again, yeah, closes that. Can I run the, all right, here's the date app. We'll see if it runs out of memory or not. Yep. And slow, but it's working. Yeah. Okay. Now, since I'm running this on NTSC monitor, the OK is actually should be where the way they did this is they just let the length of the text dictate it, but the OK is actually down here, believe it or not. It's somewhere here. There it goes. I've just gotten used to it because I used to use this in the US on a TV. Here's the calculator. There it goes. Have to maybe hit it 3 or 4 times. Again, it's the click that it's not sensing. Okay, we've got, let's just do a simple arithmetic operation. We're going to say, there goes 7 divided by 9, and then equals. There it goes. Yeah, so the calculation is actually pretty fast. You just can't get the interface elements very quickly. Close. That part's annoying. Just trying to get it to close. There it goes. All right, one other thing to do, and this is going to be hard because I can't see the numbers as they move, so I'm just going to have to just click a bunch of times. So it's going to be, there's 1, 2, let's do one more. There's 3, and so there it goes. So it's just showing that it can. Again, it's the how it reads the difference between the mouse clicks is where it gets kind of dodgy. And so, yep. And it's just going to show you that it's going to actually give you a list of, I don't know which one I did, MDV3 or MDV4. And then the final thing I'll do is, which one? MDV4, yeah. So there'll be a bunch of things in there because it's the C compiler. So yeah, so you can see that it's slow, but it's kind of working. So, all right, I want to show you one more thing, And for that, I'm going to reboot and I'll set it up. So I will be back. Here we go. All right, I'm back. So I've got my ZX simulator, which is an emulator running. So just like on the Linux system, an emulator, I have a little while, just a loop that's going to increment, and I'm going to load 18 of these jobs. So let me do that first. And actually, let's see first how it runs before I do that. And you can see that, yeah, it runs pretty decently. Okay, I'm going to stop it. I'm going to go back to this, and I'm going to hit. And so this is going to run 18 jobs. And for that, I'm just going to fast forward so that I'm not wasting any time. All right, we're back. I'm just going to go here and clear the screen. Oops. Yep. And now I'll just run it. It's slow, but it's running emulator with 18 of those loop programs. Again, unexpanded QL, 128K memory. Can't get into ICE now, I have no memory. But yeah, just wanted to show you what that looks like. So pretty decent. Again, so this is actually an emulator where it draws the characters. It's not just using a built-in character set, so it's slow. All right. So yeah, you could see that I did start bringing the Linux system a little bit to its knees. It wasn't, it started having some idiosyncrasies, although still in general it ran pretty well. And again, the QL, you saw me running 43 jobs, and its graphical interface was doing a pretty good job. And also when I ran my emulator, just to give it more of an apples to apples to the Linux system, and I could run about 18 jobs, and it would, it'd still run reasonably okay. And it still had very similar behavior to the Linux, which I found really interesting. Unfortunately, again, with the Amiga, you go past 3 or 4 of those small jobs, and the whole thing comes to its knees. So, I wish that I could figure out why that's doing that. However, let's do a real comparison to the Amiga to any computer back in the 80s when these things first came out. And I know this is a 1992 Amiga, but this is true for the Amiga 1000. I like this lines program, but I can run that on the QL. But I think what really made the Amiga shine was not necessarily that it had multitasking. I think that was an additional feature that made it kind of exciting. That differentiated from the Atari ST. But to me, this is what really makes the Amiga shine. The fact that it could do that. It could literally do a ray-traced graphics program that, could run smoothly like that. If you, the QL, best it could do was one of these, I think it's a German, what's called Kugel demo, where it does a bouncing. It's just a little animation of bouncing balls. And it's pretty grainy, and obviously only 3 colors, but nothing compared to the smooth, glassy texture of those balls as it's bouncing. I think that's pretty cool. So yeah, in the end, I think the Amiga is going to be king of the systems of the 80s, because it's a combination of maybe the exec kernel wasn't great, but could do its job. But this is really what you wanted from the Amiga, the graphics ability. So I'll end there. Thanks for joining me today, and I'll see you next time.